this example together, talk about it instead of typing today. So what we really want to get the idea is, and I know you watched the Khan Academy video already, so maybe you're starting to get an idea, but let's talk about this idea of a sampling distribution. Right? We know what distributions are. This just looks like a histogram that we're looking at here. So we have this histogram here. It's very normal. We have frequency over here, but down here we have this new term, and it's called the sample proportion. So let's try to figure out what is in this picture. So we have a population, among the population of all adults, exactly 70%. So somehow we know what all adults think. We'll talk about why that's not possible, but for now we're just assuming. We know of all the adults, 70% do not feel comfortable in a self-driving vehicle. It says the author just knows this. This TE connectivity survey of 1,000 adults, they did it, and they found that 69 said they do not feel comfortable in a self-driving vehicle. So they sampled 100 adults, and of those adults, 69% I said, I don't feel comfortable. And then, empowered by visions of multitudes of driverless cars, 50,000 people became so enthusiastic. So this is 50,000 other people. They said, well, I'm going to do my own survey of 1,000 randomly selected adults. So we have all adults in this pool. That's our population. And we're going to sample 1,000, and we're asking the question, do you feel comfortable, yes or no? And we're reporting the percentage that does, right? So if you could imagine here, this is 50,000 different samples. So in this here are 50,000 samples, and each of the frequency, right? Because this is, so down here, let's try to find exactly, can we find any number that's nice? I don't know. We're going to say that this one right here is right at 4,000. So what does this number mean right here? It means that 4,000 of those 50,000 surveyors found a, what is that, 60, this is 68, so this is 70, so this is like 68 and a half, right, percent said, I don't feel comfortable, right? So each one of these, all of these things represent all of the different samples that they did. And we put them together and we end up with a normal curve, all right? And what we're gonna kind of look at this lesson is, you know, how many sample proportions we do we end up with this idea here? Here was what we said the population was. The population is 70%. And look what we found with our mean, right? We also found a mean that was 70%. And the question is, well, if we did lots of different samples, would we always end up with this kind of distribution? And that's what we're going to look at in this lesson is, what are the shapes? If we kind of go back up here to the TSW, what does it mean to have a sampling distribution left skewed, right skewed, or neither? All right, and why are we doing this just while I'm here? Because we want to be able to take a sample and we want to know that it represents the population. We're going to make some sort of inference about the population. And we're not going to be able to take 50,000 samples all the time. So we kind of want to know the numbers we get, the mean and the standard deviation we find from a sample. Well, how is that going to help us make an inference about the population? And that's kind of where we're headed.